In this lesson, we'll be looking at applying the understandings that we've built with quadratic equations over the last week or so and at the end of last year into a maths-based task. Now, this is going to challenge you a little bit more purely because you have to make choices. And the choices will be about which is the best way to solve the problem in front of me. So as you can see, I've got a bunch of examples below. I'm going to go through and explain some choices. They'll be pretty quick applications. So this isn't for learning the skills, this is for making decisions and then using those skills to solve in whichever way we choose. So obviously your choices will involve an array of different skills for solving quadratics. So the first one might be to factorize. And when you factorize, you've got all sorts of different things you can do. It can be a common factor, it could be DOPS, it could be decomposition. So remember, DOPS is that a plus b, a take b factorization from a squared take b squared. Decomposition is using that a, c, and b. And there's monic and non-monic techniques there. And if you factorize, obviously the idea is that you're looking for it to be equal to 0, and then you can use null factor theorem. Okay, so that's one skill. We'll look at that. You could use quadratic formula. So that old chestnut where you've got x is equal to negative b plus or minus the square root of the discriminant on 2a, where the discriminant is b squared negative 4ac. You could isolate, you could complete the square. So there's lots and lots of little skills that you have to choose from, and sometimes the way that you take won't be the quickest way, but if it works for you, then that's okay. So let's look at the first one. We're looking to solve for x, and we've got x squared take 25. Now, obviously there's two approaches here. I'm going to say the easiest approach is to isolate x. So if we add 25 to both sides, and we've got x squared is 25. And then if we want to get x on its own, we have to square root. So x is equal to plus or minus the square root of 25. So I get my two answers. X is equal to plus or minus 5, or we could break that up and say x is 5 or x is negative 5. Now the second one I'll look at in a slightly different way. So let's say that we can write this one as x squared take 98 is equal to 0, so we can add that across. So the other approach would be that if I look at this as a difference of perfect squares, like x squared takes square root of 98 squared, then we can factorize it. So we can say that it's x plus square root of 98, and x take square root of 98 is equal to 0. And we can use null factor theorem to say our two answers are x plus square root of 98 is 0, and x minus square root of 98 is 0. And when we isolate, we get x is negative square root 98, and x is square root of 98. Now really, that's the same question two different ways. You can make a choice about how you want to do it. I know from experience that most people prefer option number 1. They really like to isolate square root. Hopefully you don't forget the plus minus. Okay, example 2. We're looking to solve for p. So there's no x this time. We're doing a solution for p. We can't use null factor theorem because this is not 0. So what we'll have to do is we'll have to expand out and we'll have to isolate, and then we can make a choice about how we want to solve. Maybe we don't have to expand out because we could also divide both sides by 5. And I think that's probably the best approach. So if I divide by 5 on both sides, I get p squared take 3. That's nice. And how many times does 5 go into 705? So it goes 20 times into 100. So 20 times 7 is 140. Plus one more, we get 141. Next step is, if we want to take the isolation route, is we can add 3 to both sides. And now we've got p squared is equal to 144. That should be a nice, happy, familiar value. And when we square root both sides, we end up with p is equal to plus or minus square root of 144, which gives us plus or minus 12. So it means our two answers are p is equal to 12 and p is equal to negative 12. So obviously we could have expanded out and made that a little bit more painful for ourselves, but the idea is to make it as simple as possible. And these 3 questions that we've done so far have all involved the same skill. So it's just isolation of the variable. Okay, so next one, example 3. We're looking to solve. The whole thing is equal to 0, but we've got this here. Is that square make it harder, or is it unimportant? Because we could write this, we never would because it's just painful. We could write this as 4x take 9. 4x take 9 is equal to 0. Now this whole thing is equal to 0, so what's our real approach? It should be that we can use that null factor theorem. So that null factor theorem means that each of these brackets will be equal to 0, and since they're the same, we don't have to write it twice. So straight away, our goal should be null factor theorem. This is equal to 0. So here we are, we've got 4x take 9 is 0, and it's a nice easy solve. We add 9 to both sides, and we've got 4x is 9, divide by 4, and our answer is 9 on 4. So our solution is that simple. If it's already factorized, then it's already equal to 0. Okay, so we've got another one here, and hopefully what we just talked about is a bit of a giveaway with this question. We've got the same thing, it's factorized. It's factorized and it's equal to 0. So that means each of these factors can be equal to 0, and therefore our solution is nice and simple. So null factor theorem again, we can say that m on 6 is 0, or m take 10 is equal to 0. Then it's just a matter of isolating. Multiply by 6 and we get m is equal to 0. Add 10 and we get m is equal to 10. So here we have 2 nice easy solutions again. It just comes down to manipulating that quadratic. The next one, a little bit harder, but this pattern is something we've looked at over the last week, and that's a quadratic. If it's a quadratic, we could probably also say it's a monic quadratic because there's no value in front of that x squared. It's an implied one. So that means we can use decomposition. We can use a, c, and b and look at, okay, so 1 times 90 is 90, and we've got 19 here. So we're looking for what multiplies to give 90 and adds to give 19. So hopefully we can see that that is 10 times 9 and 10 plus 9. Once we've got those two values, because it's a monic, we can just rewrite it straight away as x plus 10. X plus 9 is equal to 0. Factorized, equal to 0, null factor theorem. So now we can say that x plus 10 is 0, x plus 9 is 0, and therefore x is negative 10, and x is equal to negative 9. So the goal for this one was recognizing that quadratic, using our decomposition, and as soon as we factorized it, we can go through that process of applying null factor theorem and isolating. What's the secondary method we could use here? We could have just used quadratic formula, if that makes you happy. Okay, so we're up to the last one. The idea should hopefully be the same. We need to work out a way to isolate. Now, there's a hard way to go about this. I'm not going to do it. I'm going to take the simplest approach. And the simplest approach here is, this is a problem. We probably need to get rid of it. So the idea is that we'll expand this, and then we'll try to make the whole thing equal to 0. So expand, I left a step out there. We probably also want to factorize. So expand, get it equal to 0. If we can factorize, then we can use null factor theorem. So let's start by expanding. Y plus 1 all squared. Now, for me, I like to remember that a plus b squared pattern, where it's going to be a squared plus 2ab plus b squared. I'll show you quickly both ways that we could go about this. So if you don't like that pattern at this stage, I do implore you to practice and get to a point where you feel really confident with it. But if you don't remember that, you can say that y plus 1 squared is y plus 1 multiplied by y plus 1. We've still got our 4y plus 4 there. If we expand this out the long way, Then we've got y times y, which is y squared, y times 1, which is y, 1 times y, which is y, and 1 times 1, which is 1, and that gives us y squared plus 2y plus 1. Now, if you remember this pattern straight away, the alternative there is to just use the pattern and go, okay, so a squared is y squared. 2 times y times 1 just gives me 2y. And then 1 squared is 1. So we can jump to that y squared plus 2y plus 1 in one line if we know that pattern. All right, now we're going to try to make the whole thing equal to 0. So I'm going to subtract 4y from both sides. That gives me y squared take 2y plus 1 is 4. Now I can subtract 4 from both sides. And I've got y squared take 2y take 3 is 0. So we've achieved what we wanted. It's now equal to 0. Now I can factorize and hopefully use null factor theorem. Okay, so this is a quadratic. I can use decomposition. A times c is negative 3. This is a beautiful monic quadratic. And b is negative 2. So that means to get negative 3, we can use negative 3 times 1. And that also means if we go negative 3 plus 1, we get our negative 2, so it does work. Being a monic, we can jump straight to our factors. So y takes 3, using our negative 3. Y plus 1, using our 1, is equal to 0. And now we can finish off by applying null factor theorem. Y takes 3 is 0, or y plus 1 is 0. And our two answers are y is equal to 3 or y is equal to negative 1. All right, so hopefully you can see a little bit of the thought there. Null factor theorem pops up a lot. Isolating pops up. Don't forget that you need to do the plus minus when you square root to isolate a variable. And you've got all these different options. So if you think that you can go through with a strategy and you hit a dead end and you go, well, that didn't work, that's fine. Cross that out, start again. That's a way that you learn the correct processes and concrete in the processes you use to solve. Okay, so there's more of these types of questions in the maths-based question set. It will be quadratic equation practice. Make sure you do as much of these as possible and get to a point, hopefully, where you're fairly confident with these processes.